Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's webcast, Application Development. In the Cloud, It's Not the Same. It's brought to you by Information Week and Dr. Dobbs, as well as Zend and the Broadcast Division of United Business Media. I'm Andrew Binstock, the Executive Editor of Dr. Dobbs, and I'll be moderating today. We want to make sure this event is as interactive as possible, so I'd like to make a few announcements before we begin. There are interactive elements that will appear during the webcast, and we would like to have you see them, so please disable any pop-up blockers if you haven't done so already. This webcast also includes polling questions, and when we're ready to ask a poll, you'll see the question appear in your slide presentation window. Please complete the polls when they appear by selecting your answer within the presentation window and then clicking the Submit button. Thanks in advance for your participation. The information you provide us helps us deliver the content at the level that will interest you most. Speaking of participation, you can join our interactive Q&A session at the end of the event by submitting your questions at any time during the webcast. Just type your questions into the Ask a Question text area below the media player window and then click the Submit button. The slides will advance automatically throughout the event. If you'd like, you may download a copy of the slides by clicking on the Download Slide button located below the presentation window. If you're experiencing any technical problems whatsoever, please click on the Help link below the media player, and it will take you to our webcast help guide. You can also contact our live technical support helpline, whose number is located within the guide. And now on to the presentation. Application development in the cloud, it is not the same. Discussing today's topics are Charles Babcock, Editor-at-Large at Information Week. Charles joined the publication in 2003. He is the former editor of Digital News, former editor of Computer World, and former technology editor of Interactive Week. Charles has been following the clouds, I am told, since before there was rain. Andy Goodmans is the CEO, co-founder of Zend Technology, which is the leading provider of products and services for developing, deploying, and managing PHP applications. He has been instrumental in establishing PHP as a technology platform of choice for web development and has consistently championed the benefits of PHP openness and standardization. As a result of his efforts, today more than one-third of the web runs on PHP, and it is used by an estimated 5 million developers worldwide. Zend products are deployed in more than 30,000 companies. We will start with a poll, and let's see if we can get those poll questions up. There we go. So the first thing we'd like to know is, how do you use cloud computing? And your options are, we use it only for development and testing. We use it only as our production environment. We use it for developing, testing, and production. We don't use cloud, but are considering using it. We don't use cloud and are not considering using it. If you could just choose the answer that best describes your situation and click on the Submit Answer button, we will shortly have the poll results to show you, and that will once again help guide us in our discussion of cloud development. Could we see the poll results, please? Okay. So as you see, cloud adoption is still in its early stages, but the amount of interest in it is rather high. And now I present Charlie Babcock.
Well, thank you, Andrew, especially for that comment on before rain. I wanted to point out that one of our major goals is to all the vendors, all the cloud suppliers would like development to be the same in the cloud as it is in the enterprise. And there are going to be many aids and many forms of assistance that will make it look like the development process that developers are already well acquainted with and would like to preserve. On the other hand, I'm going to highlight where it's different and some of those differences. I think the cloud, at the very least, puts a premium on automating at all costs. Its goal is a greater level of efficiency, and we achieve that by automating some of the things that we've been doing over and over again in the past. It's no secret to developers that frameworks are a good way to automate and speed up the application building process. And I think frameworks are taking over, have taken the spotlight. I think of Spring for Java developers. What I call the Zen server includes the Zen PHP framework found in the Zen PHP cloud platform. I talk to people who use Ruby on Rails here in San Francisco, making use of the Heroku cloud and the Engine Yard cloud. And then I think Microsoft is going to do a good job with Windows Azure and making Visual Studio operate in the cloud much as it does in the enterprise with some added attractions in that locale. So we're headed toward a different kind of development environment, and I'm trying to get my next slide up. Hang on just a second. We're there, I think. Could we move the next slide? Platform as a service. If you take framework and put it in the cloud, I think you get platform as a service where there are many more forms of assistance to the developer. Someday I would predict most development will take place in the cloud because developing on the platform to which you will deploy eliminates some of those pesky steps in trying to get your application into production. The development environment can help you meet the needs of the deployment environment simply by matching it. Salesforce does this through its Force.com platform, its Apex language, its Visualforce user front-end components. Google does it through its App Engine, although Google, to me, has a preference for Python, which is what Google tends to use, plus Java. But App Engine is often used for Java applications by startups in the Silicon Valley. I mentioned Ruby programmers making use of Heroku and Engine Yard. I've watched them develop special services that add to what a developer can do quickly through their cloud-based services, and we'll get back to that in just a minute. And then, of course, Zen PHP cloud platform, or in which the Zen server is found and is usable on Amazon, another cloud platform. For some reason, I'm not able to advance slides. Could we have the next slide, please? The cloud likes open source. The cloud is elastic. The cloud likes to expand when demand builds for your application and users start wanting to buy that product that you put up just today. Traffic expands. The cloud can add servers to the web application that is meeting that demand. And that's one of the reasons that the cloud likes open source. If you're going to use licensed software, when the demand builds, you need to run and check, well, how many licenses am I authorized to use? If I commission another 4, am I exceeding my limit? Will I come get an audit by the vendor and find out that I owe them a large amount of money at the end of the year? Amazon began running on Linux. It offers several forms of Linux as its lowest priced server. Then when it comes to Red Hat Enterprise, I was a little surprised that it commands a premium on Amazon EC2, which tells me that open source developers like the cloud. They like an assured production-ready system. They are more likely to be testing it in the cloud or running it in the cloud, and therefore Red Hat Enterprise commands a 22-cent per hour premium compared to, say, plain vanilla Linux at 8.5 cents. I find that interesting. Another sign that open source is a kind of premium system in the cloud. Among other things, you will make use of web services, other services which are carefully standardized. We all know how they work. They're predictable, and they are frequently part of cloud applications, can be invoked in standard ways. And if we follow the existing standards and available open source code, we will tend to circumvent that dreaded vendor lock-in. Open source acts in another way in the cloud. Can we move to the next slide? It levels the playing field through cloud APIs. NASA built the Nebula Cloud and then contributed its server provisioning to the OpenStack open source project. Rackspace had a storage system that it contributed to the OpenStack open source project. And that project is moving along at a rapid rate to build a full-bore cloud provisioning or end-user provisioning, but cloud operating system. And it is designed primarily for the cloud providers. It's a large-scale system, but I suspect some enterprises, if they get deep enough into private cloud, building it out in their data center, they may be invoking OpenStack. I liked the Zend-sponsored Simple API. It's backed by Microsoft and IBM, but I am unsure of the uptake of it. None of the parties backing it as a major cloud vendor, and the APIs that are getting the widest adoption, of course, like EC2, are coming from those brute force infrastructure as a service vendors. Nevertheless, Simple API, if you use it in your application, would allow you to access a storage service in Amazon or a storage service in some other cloud using that same API. All you need is for the cloud vendor to support Simple API.
Charlie, I think they support Amazon and Rackspace currently. Is that right?
And that's where they started out. I would expect that to expand. Amazon, of course, is supported because its APIs have been made open source by the Eucalyptus open source project.
Okay, great. Thanks.
And that was built into Simple API. Nebula Director is what I would call core open source, but they will add features on their cloud operating system and charge for that. It's not strictly speaking a straight open source system. Eucalyptus Systems, somewhat the same vein, but they are the ones who have mimicked the Amazon EC2 APIs. Amazon has tolerated this. I think Amazon wants lots of private clouds built with Eucalyptus Systems because they will work well with Amazon's own cloud. Amazon itself, however, has not made its APIs open source, and we have to rely on Eucalyptus to keep those APIs up to date. OpenNebula is simply the NASA project spun off from its Nebula Cloud, and then, of course, the primary languages in the cloud, to me, are all open source: Java, Ruby, PHP, JavaScript, Python, etc. Can we have the next slide? Some things about the cloud as a physical platform. It is different from the servers in the enterprise data center. The cloud insists that we scale out, not up, and that means we don't go out and buy a bigger server. We add servers to a server cluster, and we try to get that cluster to operate as one computer. The cloud itself, to me, is made possible by a kind of technology convergence. There's not so much anything brand new in the cloud as several powerful elements flowing together, such as the multi-core servers, virtualization, memory caching, where a server cluster's disks and memories are treated as memory pools, and you're able to make use of the whole pool as opposed to one server's random access memory. All of this tells me that this new platform is headed toward a new problem, which is once we get lots of virtual machines running, making use of all that pooled memory and all those pooled cores, we're going to have I/O congestion at the ports of the server. And that means we are headed toward converged networking, where the storage traffic and the communications traffic has to go off the server in one stream, and it will tend to get separated out in the network fabric. All of this, I think, takes a little more know-how than the typical single-server enterprise application. So I highlight the differences of the cloud platform as some things to learn further down the road as the applications grow larger and the company becomes more dependent on that application. We're still early in the converged computing, converged networking field. Cisco entered this field in order to become a server vendor. They move that converged traffic off the virtual machine, off the hypervisor and its server out into the network fabric, and that gave them entree to the server market. We are about to see HP respond more persuasively or more directly to that challenge. They will be partnering with, this is not announced yet, don't rush this into your local newspaper, but HP will partner with eGenera to get a full converged cloud system with converged networking, something that it's been struggling to do itself, and ramp up its competition with the high end of what Cisco has brought to market. I find this competition interesting. Cisco packs its server with a lot of random access memory. Future cloud servers from HP, from Dell, from Fujitsu will be packed with cores, packed with memory, packed with disk, and then packed into clusters, and that cluster will be the computer. It'll all be operated as one system. This is a big change in how we manage the computing resource, and I think the enterprise will be very eager to take advantage of it, both internally and externally. Applications will look a little different as all of these converged resources become available to them. So let's move to the next slide and say how applications look different in a cloud architecture. I think applications, developers already do this. They already know modular applications are desirable, are a goal. Services-oriented architecture has pushed that concept deep into the enterprise. Many people in their new applications are seeking to develop modular applications. If so, you're on the right track, because in the cloud, any part of the application that needs resources can get them. And you should not allow one part of the application to hold the others back when one part needs more resources. I would give the example of Sony Music ran an online Michael Jackson store and thought that it had lots of resources behind it. It certainly had plenty to serve existing customers until Michael Jackson died. And in the next 24 hours, it was swamped with people wanting information about his music, his life, his background. They wanted to post comments to the comment wall in the store, and they wanted to buy music. The thing that lost out in that set of transactions was the financial transaction. They simply were, their servers were tied up trying to serve information, trying to collect comments, etc. And Sony Music management understood that they had lost a lot of business, a lot of sales during that intense period immediately following his death. Their solution was a more modular approach to their store application with the ability to switch information requests out into the cloud if those requests began to impinge on completing financial transactions. To me, that's a great lesson in how our applications need to be modular and how we may one day split up our applications between the internal data center and the cloud. Cloud architecture has another key concept that is not typical of the enterprise data center, and that is it assumes that hardware is going to fail. And that's because it's built with commodity parts. Google has pioneered this area and built data centers where it strips away all redundant parts on the server. They don't want redundant parts. They assume when the hardware fails, they will cope. So instead of a second power supply, which many companies buy for their data center x86 servers, Google simply puts a small, cheap lead-acid battery on the server. If the power supply fails, that battery will keep the server running long enough for the workload to be shifted someplace else. The server is not repaired. It lies there dead until probably a technician comes along and simply replaces the whole thing. It's possible that they repair some and then put them back into service as they see fit. But they've used the cheap lead-acid battery as a replacement for an expensive part. And of course that battery can be taken off a dead server, applied to a new one, reused over and over again, driving down the cost per server. If you're installing hundreds of thousands of servers, Google is, guesstimated, Google will not say, but they probably operate 1 million servers around the globe. My estimate in my book was 600,000, but that was in the fall of 2009. And I think I was trying to be conservative at that time. Google has never challenged that estimate. It's never corrected it. It's never filled me in on the exact number of servers that they do use. But you can see how at that scale you want the lowest cost server. You want an application that runs on commodity parts. And then an obvious point, we have to get into managing based on policies, things like identity management, the role and privilege level of the end users coming to the application. That type of access has to follow the end user around from application to application, and somehow has to be built into both the application and cloud architecture. Let's move on to the next slide. Just wanted to say a quick word about we want to target more than one cloud. At least I think that's a goal that many application developers would entertain because then we could move our application from one cloud to another if we found financial benefit in doing so. But there is a potential vendor lock-in with the hypervisor. You will probably start out looking at, well, what do we use internally? We use VMware's ESX server. All right, we will plan this application to run with VMware ESX server. Applications are portable, of course, across hypervisors, but there may be tweaks. There may be connections to the management system that you build into your application. So you will need to know what is the target hypervisor, or better yet, you will be able to build for multiple hypervisors with cloud system and the hypervisor itself making adjustments to your application when it views it. But these vendors listed here, all in one way or another, offer a multiple hypervisor approach. CloudSwitch in particular claims it can set up an isolation layer between your application and the enterprise data center and the part of it or the duplicate of it that you want to run in the cloud. And it translates through that isolation layer to whatever the cloud's hypervisor is. So you don't have to change anything. And all the things that work with your existing application then theoretically work in your target cloud. I need more feedback on that and how it works, but it's an intriguing idea that might get more people to the cloud more quickly. Let's move to the next slide. And I'm sorry, I've got to, Windows is blanking me out. Yes, okay. Managing the invisible application, we have a new feature of applications I think needs to be built in, because once your application moves to the cloud, it doesn't become invisible. You can tell whether it's still running, but that's about all you can tell, at least in terms of today's cloud. And that's a troubling thought. With your systems management in the data center, you know a lot more than that. You can learn a lot more than that. You can get the server log if you need to and review performance. Wiley Technologies built a Java application management system called Intrascope, if I remember right. And it could tell how well different parts of the Java application were running. CA bought Wiley and now still offers Intrascope as a way of monitoring Java applications. I think the things that Intrascope is able to do will one day be built into the cloud application. So the notion of introspection, how do you get that into your application? I would say that's going to become a hot topic in the next year or so as more and more applications are designed for the cloud. Topology mapping. What does this application use? Where are the resources that it's making use of? Dependency discovery. This cloud application needs that database. Can it access it from there? If the database is also in the cloud, do we know what server it's on? Do we know whether it's running or not, as well as the application? That kind of dependency is vital information by the time you've moved your application into the cloud. RPath and a number of application tool vendors will provide change control as you build, rebuild, reissue your application for production, but change control will be an absolute necessity by the time we start sending applications out to the cloud and perhaps modifying them there. We would like to develop once and then run anywhere. That's kind of the root goal of what I'm talking about here. That's never really happened in the past. When we come to hoping to run on multiple clouds, that's what we're shooting for. And so I would always ask anyone who tells me they can do that, really, and let me talk to your customers, because I'm very curious whether they find that that's true. Let's move to the next slide. The other thing about application development for the cloud is that you will see your basic disciplines in the data center start to merge. One thing that happens in the cloud is that end users self-provision. For that to happen, for an end user to be able to simply select a server, the network administrator, the server administrator, the security officer, the storage manager, all have to merge their disciplines and create a server template. The end user is going to have a limited set of choices in the cloud, at least the way I think that it's going to operate. Those choices need to be very carefully engineered by a set of merged disciplines up front. If the end user says, I want this kind of server, and the server administrator whips it out because virtualization makes it quick and easy to provision a server to order, maybe it's going to violate something that the storage manager wishes to enforce if we don't have the storage manager present at the creation. Applies to all those disciplines. Another example of this is managing the application itself will tend to merge disciplines. The management system vendors realize this, VMware realizes this, and VMware in a way has stolen a march on the better established system managers by merging three disciplines into the virtual application management. System configuration, performance management, capacity management can all be done through vCenter operations. So this is an example in the flesh of the merging of disciplines that will take place in the cloud. In the end, the operation of the application must inform development. Developers will have to accept feedback of how their application is doing in the cloud in order to understand how best to develop the next application and keep the ones they've got running.
Charlie, this merging, I think, is one of the many definitions that I've heard bandied around for DevOps, and I think, as you say, is probably going to become a way of doing things in the future, and may very well spill over into even non-cloud environments where those practices will become standard both from the developer's point of view. And
I think what developers will be called on to do will be to instrument their application in some fashion. How long did that transaction take? There will be some agent that reports in if it starts rising above a certain threshold, something like that.
Okay, before letting Charlie continue, I think if we can get the next slide, I think we have another poll question. And so we're curious to know where, if you are using or are planning to use the cloud, what kind of cloud are you looking at? So the options are the public cloud. Those would be the ones outside the firewall, such as Google App Engine, Amazon, Microsoft Azure. Private cloud is inside the firewall. Both public and private clouds, or don't know. If you could just take a moment to choose the options that best describe your site's configuration and hit Submit Answer. We'll look at the results in just a moment.
And of course, we're shooting someday for both public and private clouds to be used by the enterprise in the manner of hybrid cloud. That'll be the final point.
Right. Probably with a strong bias towards the public cloud, I would imagine.
The public cloud will be the expert at building x86 infrastructure.
Right. Okay, if we could have the poll results, let's have a look. Okay. So just as you predicted, Charlie, it looks like the hybrid cloud is the one that is so far gathering the most traction, followed by public clouds.
That's right, and that saves me doing one slide because I was ready to state that the ultimate goal is to get to the hybrid cloud. Our listeners have already made that point for me with the 34.5% oriented in that direction. Yep. Let's go to the next slide. Just a quick word on what applications belong in the cloud. Everyone has a right to their own ideas on this. The application you decide to put there is the right one in the cloud. My answer is a short one. All applications belong in the cloud. But we're not there yet. To get started, the customer-facing applications, the applications that serve up product information, the product catalog, pricing information, all of that is public information. Why not put it in the cloud? Why not let the fluctuations in demand be served by the cloud with its ability to expand and contract? That way you pay for what you use. Any application with a wide variety of demand is one to consider for the cloud, and many website applications will experience this. Even if it's a transaction application, we are close to the point where it could be put in the cloud and be PCI compliant. This is still not a fully understood art, but the PCI Council has acknowledged at the start of this year, if you run your application in a virtual machine, it can still be PCI compliant. Until January 1st, they had not put that statement on the record, and therefore PCI in the cloud was out of the question. There are now PCI auditors that will authorize PCI compliance as being accomplished in the cloud. You have to, the developer and the enterprise operations staff has to assure they're meeting PCI compliance from their end, and then the cloud assures the auditor it's meeting PCI compliance from its end, and the connection is examined, and if secure, you get your PCI compliance. So to my mind, any application in the near future is a candidate for the cloud. But those with perhaps a short life cycle, a department wants a new application, you know they're going to run it for 6 months as a kind of campaign application, and then they're going to abandon it. But when it comes time for it to be shut down, they will be reluctant to give up their resources in the data center. Why not try to get that application into the cloud? It can run for the 6 months. If they wish to continue running it after its useful life cycle, they will be presented with a bill, not IT. And that is a good discipline, a good check on the end user's desire for endless resources. In the cloud, you have to pay for them. If it's mission critical or if it's a production application, you of course need a way to recover from a failure. And the server may fail underneath it. The data center itself may fail. But the cloud vendors are getting skilled at providing failover disaster recovery type of solutions. It requires you to either have in reserve with a delay or on standby live a second server or a second set of servers, preferably in a different data center, or as Amazon would say, in a different availability zone. I think many cloud data centers have two sources of power. One can fail and darken part of the data center momentarily. The other is still available and things are shifted over to the part of the data center still getting power, or shifted elsewhere through the wonderful virtualization characteristic of live migration. So let me wrap up here. Everyone will eventually figure out which of their applications are best to run in the cloud and then start designing them with those cloud characteristics. I believe eventually you'll be running part of the application in the data center as Sony Music did, and part of it in a public cloud where the cheapest infrastructure can be built and made use of with a high rate of utilization by many customers. And that will be a combination known as a hybrid cloud that will be hard to beat. And thank you very much. Back to you, Andrew.
Okay. Could we have the next slide, please? Okay, and I think we can go one more. I think we've got one more poll. If we could get to that poll. Okay. And the poll is, what is your primary programming language for building web applications today? Since it's asking about the primary language, there's please just choose one of these from PHP, Java, one of the .NET languages, Ruby, Python, or Perl. And then after you've made your selection, please hit Submit Answer. And in just a moment, we'll see which ones come out on top. And I'm guessing it's going to be a tight race between PHP, Java, and probably .NET. This will, of course, get all the Ruby folks clicking on Ruby. Okay, let's, if we could push out the results slide, let's have a look at that. Well, there you are. See? Excellent. So, okay. I would have expected those results, as I said earlier, and we see that Java still is number one, just by a little bit over the .NET family of languages, with PHP very much in that mix and an important part of that equation. And with that, let me hand the microphone to Andy Gutmans, who will talk more about PHP's particular suitability for the cloud.
Great. Thank you very much, Andrew. So as Andrew introduced me, I'm Andy Gutmans. I'm the CEO and co-founder of Zen Technologies. I'm also one of the original authors of PHP. And what I'll talk to you about today is how we see application development in the cloud. A lot of what I'm going to be talking about Charles actually hinted to, and I think a lot of it is relevant to all languages, not only PHP. So I'm also going to try and keep things also at a more generic level. When we think about what is the ideal application platform in the cloud, I think there are a variety of tenets that you should be thinking about. The first one is a multi-cloud. If you're using a cloud platform to build your cloud-native application to, are you using a solution that can actually help support you in multiple cloud environments? Really give you the choice to deploy on, Amazon, Rackspace, and a private cloud environment based on your needs. The various clouds have different advantages and disadvantages, and you definitely want to make sure that you keep all your options open as cloud continues to evolve and as your business needs may be changing. We believe the application is at the center of the cloud, and really the cloud, the same way the cloud is an abstraction layer of your hardware, or virtualization is an abstraction of the hardware. We believe that cloud platforms that focus on application development should also give you an abstraction of the resources that your application is consuming. And so what we're focusing on, and I believe a lot of other cloud platform players are focusing on, is really taking you away from the server view of the world and providing you a much more application-centric view of what's happening. Both application-centric view, service-centric view, and of course give you a management layer that really focuses at the application at hand. And it becomes increasingly important with cloud because, as Charles alluded, over time there may be a gray area of what resources are actually participating in serving your application. It could be multiple VMs. It could be containers. There could be some bare metal within the firewall. So the way you really want to think about managing your applications is at the application level. Lifecycle becomes increasingly important. It's always been important to application developers. I do believe the cloud provides a unique opportunity to improve the application lifecycle. As Charles pointed out, providing you the consistency from development to test to staging to production is something that has always been a challenge. With cloud, spinning up another development environment, another testing environment in a way which is very, very consistent becomes very easy and very cheap. And so the tools that you're actually getting from leveraging cloud computing and some of the solutions that are being built are going to really help you streamline your whole application lifecycle. Portability is critical, and there are a lot of cloud management vendors that are helping with portability and are going to enable you to run workloads in a variety of areas. Charles mentioned Simple Cloud, and I'll get back to that in the next slide, but that is a project that we started that helps support portability at the application level. So most of what you're seeing today is at the infrastructure level. Really cloud management providers who help you run workloads in a variety of cloud environments. Our focus, coming at it from the app dev layer, is around building applications that can actually then, be portable across the variety of clouds. And the last but not least, and this is the Michael Jackson example from Sony Music, which I also know, pretty well, is the elasticity aspect. You have seasonality in your businesses. Sometimes you're growing faster than you anticipate. Sometimes you can save resources and scale down your applications at certain times. So having a platform that really helps you also scale up and scale down to meet the demand, the current demand of your business, can both help you accelerate your business, plus it can also help you manage your costs. So Simple Cloud was mentioned before. Simple Cloud is an initiative we led with IBM, Microsoft, Rackspace, and some other companies. Really, what Simple Cloud tries to do is provide you an abstraction between the cloud application services that some of the cloud vendors offer, such as storage, DB, queuing, and the application layer. And today we support Amazon, Rackspace, we support Windows Azure, and we have some other cloud services that we support. And what it really is it's a common API that if you're building an application that is cloud native, so not moving a legacy application into the cloud, but really building a new application that's going to take advantage of services such as Amazon S3 Amazon Database, Amazon SimpleDB, and other applications, that you can write that application in a way that doesn't lock you into a specific cloud vendor. And that works in conjunction with cloud management solutions that help you get portability on the infrastructure layer. So we believe Simple Cloud is a very important strategic project. We think it's going to be very important for you. It's correct that it hasn't gotten that much uptake to date, not so much because Simple Cloud isn't there, more because the cloud application services being offered by the cloud infrastructure providers, generally speaking, are still pretty immature. But we believe that over time, those solutions are going to become more and more robust. So you already see today a lot of usage of Amazon S3. I think some of the database and queuing solutions aren't being used as much yet. But rest assured, the services are going to improve. They're going to help you scale. I think you're going to see a lot more value-added services, such as credit card services, media services, and other services that ultimately are really going to give you a huge amount of benefits. And we're going to be there helping you leverage those services on one hand, but then also making sure that your application isn't locked into a very specific cloud environment. What we're building out at Zend is a Zend PHP cloud platform, and it really addresses a lot of the areas that Charles mentioned earlier. So it's a cloud platform that we are going to help deploy on multiple clouds. We're going to also offer that as a service, and it's going to give you the most reliable, performant platform to build your cloud-based PHP applications. For those who aren't very familiar with PHP, PHP runs close to 40% of the workload in the cloud. It really is, the leading cloud language, and really very, very effective, efficient, and scalable when it comes to building cloud-based web applications and web services. And so some of the components that we're focused on are Simple Cloud, as I mentioned. We're also going to give access to native cloud services. So if you don't want to use an abstraction layer, we will give you very good native APIs to Amazon, to Azure, and to other platforms. In fact, we've had contributions from Amazon and Microsoft to Zend Framework, which is the underlying framework that helps us connect to these services. And they've actually contributed to our framework to make sure that those both native services and some of the Simple Cloud services really, really work well. Charles mentioned introspection, which becomes increasingly important. That's a big emphasis of ours. That's one thing we deliver with our platform. So we actually don't only do, we really do language level monitoring. So we tell you if something is going wrong, if part of your application isn't working or it's slow. We have a solution called code tracing, which in production actually it's like a black box in production and records everything that happens, so you can have some replay afterwards and really see what went wrong. We are continuing to focus on exposing that kind of introspection at the application and service level. So you can both see what your application is doing, no matter how many resources participate in serving that application, but also at the service level. Are you having issues with Amazon S3 or other services that you're connecting to? Resource management. So really you're really moving more towards an application-centric view of the world, but ultimately underlying that there are resources that are participating in serving those applications. So definitely there has to be a certain level of management there that helps manage which resources are participating, what kind of cloud instances, what happens when you have to spin up. You got to spin up another cloud instance that has to register, it has to be managed, it has to be highly available, and those are the pieces that we do and that we take care of. Say last but not least, when I think about deployment, configuration management, and really making sure that when we scale up and scale down applications, those applications are auto-deployed, managed, and optimized. There's a big focus in this platform on just making sure that the application is taking advantage of all the resources that are available to it. And as that platform, as the workload scales up or scales down, things are adjusted and high availability zones are adjusted, and other metrics are adjusted around the platform. Last but not least, we believe developer tooling is critical. The DevOps role was mentioned before. By the way, that doesn't mean there isn't still a very structured process of how actually something gets deployed into production, but it does mean that earlier on in the process, you're actually enabling developers to build packages and deploy them into a cloud environment that is identical to the runtime environment where things are going to run in. And so we have a very big focus with Zen Studio, which is your analogy to Visual Studio for .NET, where we're creating a lot of tie-ins between the development environment and ultimately the cloud platform, and making that whole experience very seamless and very productive. So you can really focus on building your application, being very productive, and throwing that application into the cloud, and it is managed, optimized, and it can scale. So Charles mentioned write once, deploy anywhere, or I think he said develop once and run anywhere. And we actually think we can make it happen. We are making it happen today. We have a very good, consistent development environment. We've actually done some integration with VMware Workstation, so you can have your little cloud instance on your desktop. We also enable you to connect to a cloud that's actually in the public cloud and develop on that, and really give you an environment that helps you focus on building an application on a platform that is completely consistent across different production environments. And then we're actually later this month launching an offering where you're going to be able to take that application and initially deploy that seamlessly into the Amazon and Rackspace cloud. And those clouds are going to be fully supported. We're going to support elasticity in those clouds, management, and you will not have to change a single line of code to actually make that happen. Over time, we're going to add additional support for a variety of clouds, so you can truly focus on being productive at the application development level, build your applications, and then throw it into production on whatever environment you want, and you get all the benefits of cloud. You get elasticity, management, and other benefits that I mentioned before. So the last thing I would just add to that is we do believe cloud should also be customizable. We see a variety of needs in our customer base. And so while we're going to be very prescriptive at how you build your PHP platform, how you deploy and how you manage that, if you're in an environment, let's say you're in an Amazon and you have a very special version of Oracle that you need to use as part of that environment, you will be able to manage that as part of this whole platform and really customize it and add componentry to it to really get to the system architecture that you need to be successful. So I'll hand it back to Andrew.
Well, thank you very much, Andy. Just a quick question. The feature that you just described that you're going to be rolling out next month, does that have a name yet that you can announce?
So we're rolling it out under the Zen PHP Cloud Platform.
Okay.
It's going to be rolled out in partnership with a leading cloud management provider, which I can't name right now.
Okay.
But that is definitely going to give us the cross-platform support and the Amazon Rackspace in the future and other clouds in the future.
Excellent. I'll look forward to that coming out. Okay, we now move on to our Q&A portion of the program. Let's see. Could we push the Q&A slide, please? As a reminder, just to participate in the Q&A, just type your question into the text box located below the media player, and then click the Submit Question button. Let's see. We've already got several questions already lined up. Okay. Let's see. Let's start with one from Jeffrey, who asks, how does Mr. Goodman see Java EE 5 and 6 platforms fitting into present and future cloud architectures?
That's a good question. I'm obviously a bit biased coming from the PHP side. I was a WebSphere developer in the in the long distance past, so I I do have some clue about J2E. I do think that one of the things that is benefiting us is that Java, when it comes to cloud deployments and I would say more rapid web development, has lost a lot of attractiveness. So I think Java is still very good at the back end, transaction management, queuing, and ESBs. We do see though that as companies are transitioning into the cloud, they are looking for additional benefits such as an increase in productivity and really being able to push out web applications faster. And so I think it's going to be, realistically speaking, very challenging for J2E making that leap into the cloud. I also think that a lot of the J2E solutions that I've seen in the cloud today are more of the same legacy on top of infrastructure as a service versus what I described a bit earlier, which really gives you truly some real benefits in the cloud on taking things to the application level, helping you scale out very, very easily, and helping you deploy very easily.
Thank you. We have a question from Raghu for Charlie Babcock. What difference in performance cycle time can be noticed? And if so, what could be the bottleneck in the cloud?
Raghu, there are many candidates for bottlenecks in the cloud. One is the network segments itself that you're using, and you don't know their impact as you launch an application and try to watch it run. If there are latencies in the network, they will affect what you can see and potentially how well your application will run. There are latencies in the cloud itself because the cloud is a multi-tenant architecture. Netflix moved its applications to the cloud and watched very carefully. They discovered if you land on a server with what I would call noisy neighbors, very chatty, lots of I/O, lots of things coming and going, trying to do lots of different things that take time on the server virtual machine, that they said it steals just a few cycles from your virtual machine as opposed to a steady state neighbor who is not doing a lot of up and down type of things. So they watch their applications. If they've landed on a server with noisy neighbors, they kill that application. They relaunch it somewhere else in Amazon EC2 and do not allow that 1%, 1.5% of cycles to be stolen from them. So performance in the cloud is going to be a difficult issue, more difficult to manage than it already is in the data center. The best hope is good monitoring systems that can report in to you how your application is running and what's happening there.
Interesting. Charlie, just a quick question on something you mentioned earlier in the presentation. This is asked by Glenn, but I'm curious as well. You mentioned PCI compliance. What exactly is PCI compliance?
PCI is payment card industry. It's a standard for the credit card companies. You have to meet certain security standards to be PCI compliant, and all credit card processors are. So that's a kind of benchmark. If we can do that in the cloud, then enterprises could do many types of transactions in the cloud.
Got it. Okay, thank you. Andy, we have a question from Jim. Does one need to be careful about a runaway app in development, or are there adequate governors to limit use and hence cost on the cloud?
Yeah, I mean, you absolutely have adequate ways to govern that. So the platform that we're pushing out, you're going to be able to very specifically indicate what your MAC servers are. Obviously, in a development environment, that may be one, and so you're not going to get any runaway. So you're going to be able to, keep a very good track of how many servers you're willing, to participate. You're not going to get endless scale out unless you really ask for that. We're also focusing on some additional offerings that may make it even more cost-effective in development, and those are things we're looking at for the latter part of this year.
Got it. So you yourselves are going to be both striding the operational as well as the development aspects.
Absolutely. We think the development side is critical, and it's always been where we've started and then really taken that into production.
Great. Someone asks, is there a good place to review and understand the physical configuration of cloud computing? This is a question from Harry.
I would say no, there is not. I tried to answer that question myself when I was confronted with it. The best thing I found was a paper by two Google engineers. I forget their names off the top of my head, but it's titled "The Data Center as the Computer," and it then describes a cloud architecture, and that's as close as I've come.
Well, I think that's going to essentially wrap it up. We're running out of time here. Let's see. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. And additionally, you can view today's event on demand by going to www.netseminar, that's all one word, .com. So www.netseminar.com. Thank you for attending today's webcast, Application Development in the Cloud. It's not the same, brought to you by Information Week, Dr. Dobbs, and Zend. And now for the legalese. This webcast is copyrighted 2011 by United Business Media Limited, and which is not responsible for the comments and opinions of the speakers. Thank you very much. On behalf of our guests, Charlie Babcock and Andy Gutmans, I'm Andrew Binstock. Thank you, and have a great day.